Hello everyone, welcome back to Husky Math. Today we will learn about tangent and normals. So using derivatives we can find the slope of any straight line. So since tangent and normals are just a straight line passing through a point of a curve, so we can find their slope and write the equation of these tangent and normals using derivatives. So for that, let us assume a graph of a function y equals to fx, and if I choose a point P here whose coordinate is x1, y1, and let's make a tangent on this point. So here's my tangent at point P. So this point P is called the point of contact. This point P is called point of contact. Now the slope of this tangent at point P will be dy over dx, and we have to put the value of x and y as x1 comma y1. Similarly, if I have to make a normal on this point P, which is a straight line and is perpendicular to the tangent, so the slope of this normal would be minus 1 by dy over dx and at x1, y1. So using the slope of tangent and normals, we will write the equation of these two straight lines. One thing is to note that this point of contact is very important in this chapter, because this point P, which is a point of contact, lies on the curve y equals to fx. This point lies on the tangent also, and this point lies on the normal also. That means this point has to satisfy all the equation of function, tangent and normal. So the equation of tangent to a curve at x1, y1 is given by y minus y1 over x minus x1 equals to slope of the tangent, that is dy over dx at x1, y1. So similarly, the equation of the normal of the curve at this point x1, y1 is given by y minus y1 over x minus x1 equals to the slope of the normal. If the slope of a tangent is dy over dx, then the slope of the normal will be minus 1 by dy over dx. That means it will be the inverse of the slope of the tangent, and the signs are opposite. For example, if the slope of a tangent is 2, then the slope of the normal will be inverse of 2, that is 1 by 2 with negative sign. And similarly, if the slope of a tangent is 1 by 3, then the slope of the normal will be inverse of 1 by 3 is 3 with negative sign. So if you remember this trick, then it will be much faster for you to solve the problems. So let's see some questions now. Find the equation of the tangent and normal of the curve y equals to x cube minus 2x plus 7 at 1, 6. So the given curve is y equals to x cube minus 2x plus 7, and the point of contact is 1, 6. So in order to find the slope of this tangent, let us differentiate the given equation. So it will be dy over dx equals to 3x square minus 2. Now we have to find the value of dy over dx at the point of contact, that is 1, 6. So we have to put the value of x as 1 and y as 6. So here it will be 3 into putting the value of x as 1 square minus 2 equals to 3 minus 2, which is equal to 1. So the slope of the tangent is 1. And we know the equation of the tangent is written as y minus y1 over x minus x1 equals to slope of the tangent, that is dy over dx at 1, 6. So this implies y minus, here we have to remember that this x1 and y1 are the point of contact, that is 1, 6. So putting the value of y1 as 6 and x1 as 1, we will have y minus 6 over x minus 1 equals to dy over dx, that is slope of the tangent is 1. So let us cross multiply, then we will have x minus 1 equals to y minus 6, which implies x minus y plus 5 equals to 0. So this is the required equation of the tangent. Now similarly, we will write the equation of the normal. The equation of the normal is y minus y1 divided by x minus x1 equals to the slope of the normal, that is minus 1 by dy over dx at the point of contact, that is 1, 6. Similarly here, the value of x1 and y1 is the point of contact, so we will have y minus 6 over x minus 1 equals to minus 1 by 1, since the value of dy over dx is 1, 6, or using the short trick also, as I already said, that since the slope of the tangent is 1, so the slope of the normal will be the inverse of 1 with negative sign, so that is simply minus 1. So here it will be y minus 6 equals to minus x plus 1. So on simplifying, it will be x plus y minus 7 equals to 0. So this is the equation of the tangent. Question 2. Find the equation of the tangent and normal of the curve x square over a square plus y square over b square equals to 1 at the point a cos theta and b sin theta. So this is the equation of the ellipse. So let us differentiate the given equation. So if I differentiate the given equation with respect to x, then it would be 2x by a square plus 2y by b square. Due to chain rule, we have to write dy over dx equals to ddx of 1 is 0. Here a and b are constant. So this implies 2y by b square into dy over dx equals to minus 2x by a square. So here 2 and 2 got cancelled. So the value of dy over dx equals to minus b square by a square into x by y. So let us find the value of dy over dx at the point of contact, that is a cos theta comma b sin theta. So this will be equal to minus b square by a square into the value of x we have to put from the point of contact, that is a cos theta divided by y is b sin theta. So here a and this square got cancelled. Therefore the slope of the tangent at the point of contact is minus b by a cos theta over sin theta. Therefore the equation of the tangent is y minus y1 over x minus x1 equals to the slope of the tangent, that is dy over dx at the point of contact So this implies y minus y1 is point of contact, that is b sin theta over x minus x1 is a cos theta equals to the slope of the line is minus b by a into cos theta by sin theta. So let us cross multiply, then we will get a sin theta y minus ab sin square theta equals to minus b cos theta x plus ab cos square theta. So let us keep all the constant term on the right hand side. So here it will be a sin theta y plus b cos theta x equals to ab sin square theta plus ab cos square theta. Then we will have a sin theta y plus b cos theta x equals to, here if I take out ab common, then here it will be sin square theta plus cos square theta, and we know that the value of it is 1. Hence my equation of the tangent can be written as a sin theta y plus b cos theta x equals to ab. So this is the required equation of the tangent. The equation of the normal is given by y minus y1 by x minus x1 equals to, the slope of the normal is 1 by minus 1 by dy over dx at the point of contact. So here let us put the value of x1 and y1, then we will have y minus y1 is b sin theta by x minus x1 is a cos theta. Now as I say that the slope of the normal should be inverse of the slope of the tangent with the opposite sign. Now since the slope of the tangent was minus b by a cos theta by sin theta, so the slope of the normal will be the inverse of it, that is a sin theta by b cos theta, and with the opposite sign of minus is plus. Or you can put the value of dy over dx and you will get the same thing. So here it will be a sin theta x minus a square sin theta cos theta equals to b cos theta y minus b square sin theta cos theta. So let us keep x and y in one side, that will be a sin theta x minus b cos theta y equals to a square sin theta cos theta minus b square sin theta cos theta. You can simplify it further, then it will be a sin theta x minus b cos theta y equals to, taking out sin theta cos theta common, we will have this. Now if I divide both sides with sin theta cos theta, then dividing both sides with sin theta cos theta, then this sin theta cos theta got cancelled, here cos theta and cos theta got cancelled, sin theta got cancelled. So this implies a into 1 by cos, and which can be written as a sec theta x, because 1 by cos is sec, minus b into 1 by sin is cosec, so it will be cosec theta y equals to a square minus b square. So this is the required equation of the normal. Find the equation of the tangent and normal of the curve y squared equals to 4ax at at squared to at. So here a is constant. So the given function is y squared equals to 4ax. Differentiating both sides with respect to x, we will get 2y into dy over dx equals to 4a. So here 2 1s are 2, 2 times 2 is 4. That means dy over dx equals to 2a by y. Let us find the value of dy over dx at the point of contact, that is at square comma 2at equals to 2a by y. The value of y here is 2at. So here 2a and 2a got cancelled. That means the slope of the tangent is 1 by t. Therefore, the equation of the tangent is given by y minus y1 by x minus x1 equals to the slope of the tangent at the point of contact. So this implies y minus y1 is 2at divided by x minus x1 is at square equals to the slope of the tangent is 1 by t, so I'll have 1 by t here. So on cross multiplying, I'll get x minus at square equals to t into y minus 2at square. So this implies x minus ty plus 2at square minus at square equals to 0. So here we can simplify this too. So it will be x minus ty plus at square equals to 0, which is the required equation of the tangent. And similarly, the equation of the normal is given by y minus y1 by x minus x1 equals to the slope of the normal. Now see here, the slope of the tangent is 1 by t. That means the slope of the normal will be inverse of it, that will be t with the opposite sign, that is minus. I hope you understood this. So this implies on cross multiplying, I'll get y minus y1 equals to minus tx minus tx1. So it will be tx plus y equals to y1 minus tx1. So this is the required equation of the normal. Question number 4. Find the equation of tangent and normal of the curve at the point where it cut the x-axis. The question is saying that we have to find the equation of the tangent and normal of this curve, but at which point? At the point where this curve will cut the x-axis. So if I made a graph here for visualization, then so if this is a graph of this function, which is obviously not up to the scale, this is for just idea, and the equation of the curve is given as y into x minus 2 into x minus 3 minus x plus 7 equals to 0. And this curve is cutting x-axis at this point, let us say P. And we have to find the equation of the tangent and normal at this point P. And we know that at the point lying on the x-axis will have ordinate as 0. That means we need to find the value of x1 because y1 is already given as 0. So now how to find the value of x1? See here, since this point p x1 comma 0 is lying on the curve, that means this x1 comma 0 point must satisfy this equation of the curve. So let us put the value of x as x1 and y as 0 and find the value of x1. So let us put this x1 and 0 on this equation of the curve to get the value of x1. So if I put this point in this equation, then we will have, see, y is 0 and x is x1 minus 2, x1 minus 3 minus x1 plus 7 equals to 0. This entire thing got 0, so I'll have minus x1 plus 7 equals to 0. So this implies the value of x1 is 7. That means the point of contact is 7 comma 0. Therefore the point of contact is 7 comma 0. Because without the point of contact we cannot find the equation of the tangent. Now let us differentiate the given equation of the curve, which is y into, so if I multiply x minus 2 and x minus 3 in the next line, then I'll have y into x square minus 2x minus 3x will be minus 5x, and minus 2 times minus 3 is plus 6 minus x plus 7 equals to 0. Now let us differentiate using product rule. So let us keep y at first and differentiate the bracket, that will be 2x minus 5, and keeping bracket as constant and differentiating y, I'll get dy over dx minus ddx of x is 1 and ddx of 7 is 0 equals to 0. So from here we got the value of x square minus 5x plus 6 into dy over dx equals to 1 minus y into 2x minus 5, and the value of dy over dx will be 1 minus y into 2x minus 5 whole divided by x square minus 5x plus 6. So the value of dy over dx at the point of contact, that is 7, 0 will be equal to, let us put the values, it will be minus 0, 2 into 7 minus 5 whole divided by 7 square minus 5 into 7 plus 6. This equals to 1 divided by 49 minus 35 plus 6, and on simplifying you will get 1 by 20. So 1 by 20 is the slope of the tangent at 7, 0. Therefore, the equation of the tangent is given by y minus y1 by x minus x1 equals to the slope of the tangent, which is 1 by 20. So let us put the point of contact here. So it will be y minus 0 x minus 7 equals to 1 by 20. On cross multiplying, I'll get x minus 7 equals to 20y. So this implies x minus 20y minus 7 equals to 0, which is the required equation of the tangent. And similarly, the equation of the normal will be y minus y1 by x minus x1 equals to the slope of the normal will be, as I said, that the slope of the tangent is 1 by 20. So the slope of the normal will be the inverse of 1 by 20, that is 20 with negative sign or opposite sign. So let us put the point of contact, then we will have y minus 0 by x minus 7 equals to minus 20. On cross multiplying, we will get y equals to minus 20x plus 140. So the equation of the normal will be 20x plus y minus 140 equals to 0, which is the required equation of the normal. Question 5. So that the equation of the tangent to the ellipse at x1, y1 is this much. So here we have to prove the point of contact is x1, y1 by default, and the curve is an ellipse. So let us differentiate the equation of the ellipse both sides with respect to x. Then we will have 2x by a square, where a and b are constant, plus 2y by b square dy over dx equals to 0. So this implies 2y by b square dy over dx equals to minus 2x by a square. 2 and 2 got cancelled. So dy over dx equals to minus b square by a square into x by y. So now let us find the value of dy over dx at the point of contact, that is x1, y1, which will be equal to minus b square x1 by a square y1. So this is the slope of the tangent at x1, y1. Now we know that equation of the tangent is given by y minus y1 by x minus x1 equals to slope of the tangent at x1, y1. Now since by default the point of contact is x1 comma y1 only, so here it will be as it is, x minus x1 equals to the value of dy over dx is minus b square x1 by a square y1. Now let us cross multiply, then we will have a square y into y1 minus a square y1 square equals to minus b square x into x1 plus b square x1 square. So let us keep x and y one side, then we will have b square x into x1 plus a square y into y1 equals to a square y1 square plus b square x1 square. Now let us divide both sides by a square b square. Dividing both sides by a square b square. So here this b square and b square got cancelled, a square got cancelled, a square got cancelled, and b square got cancelled. So the equation of tangent will be x into x1 by a square plus y into y1 by b square equals to y1 square by b square plus x1 square by a square. Now here I had already told that this point of contact is very important because this point of contact lies on the curve. This point of contact lies on the tangent as well as on the normal. That is, x1 y1 must satisfy this equation. That means if I put the value of x and y as x1 y1, then this equation should be true. So if I put the value of x1 y1 here in the equation of ellipse, then it will be x1 square by a square plus y1 square by b square equals to 1. And since this value is equal to 1, that means the value down here is also 1. So from here we can put this as 1. That means my equation of tangent will finally be x into x1 by a square plus y into y1 by b square equals to 1, hence proved. Question 6. Find the equation of tangent and normal to the curve x equals to sine 3t, y equals to cos 2t at t equals to pi by 4. So here x is a function of t, y is a function of t. So we will first differentiate these two equations with respect to t. So here, since x equals to sine 3t, so differentiating both sides with respect to t, then we will have d dt of x equals to 3 cos of 3t, and equation of y is equal to cos 2t. So on differentiating both sides with respect to t, we will get minus 2 sine 2t. Therefore, the value of dy over dx can be written as dy over dt divided by dx over dt, which equals to minus 2 sine 2t divided by 3 cos 3t. Now here the main thing is to find the point of contact. For that we will just put the value of t equals to pi by 4 here in the equation of x and y. So putting the value of t in x, then it will be x equals to sine 3 pi by 4. So this implies sine 3 pi by 4 can be written as pi minus pi by 4, and we know that sine pi minus pi by 4 is simply sine pi by 4 only. That means the value of x equals to 1 by root 2. And similarly, if I put the value of t equals to pi by 4 in the equation of y, then we will have y equals to cos 2 into pi by 4. So here 2 and 2, 4 got cancelled. So y equals to cos pi by 2, and we know the value of cos pi by 2 is 0. That means the point of contact is 1 comma root 2 comma 0. So here we will write the point of contact is 1 by root 2 comma 0. Now since we got the value of point of contact by putting the value of t equals to pi by 4, so the slope of this tangent dy over dx will also get the value if I put t equals to pi by 4 in the equation of dy over dx. So let us put here dy over dx when t equals to pi by 4, then this equals to minus 2 by 3 into sine 2 into pi by 4 divided by cos 3 into pi by 4. So this equals to minus 2 by 3, here 2 and 4 got cancelled, so it is sine pi by 2 divided by cos 3 pi by 4 can be written as pi minus pi by 4. So this equals to minus 2 by 3 into sine pi by 2 is 1 divided by cos pi minus theta is minus cos theta, so it will be minus cos pi by 4. So here minus and minus got cancelled, so this equals to 2 by 3 into 1 by root 2. So this equals to 2 root 2 by 3. Now since I have got the slope of the tangent, now we will write the equation of the tangent. Therefore, the equation of the tangent is given by y minus y1 by x minus x1 equals to the slope of the tangent, that is dy over dx. This implies y minus, see the point of contact, my x1 and y1 is 1 by root 2 and 0. So here putting those values, I will get y minus 0 by x minus 1 by root 2 equals to the slope of the tangent is 2 root 2 by 3. So here let us simplify, then we will get y by, on taking LCM we will get root 2 in denominator, then root 2x minus 1 equals to 2 root 2 by 3. This implies root 2y by root 2x minus 1 equals to 2 root 2 by 3. So on simplifying we will get 4x minus 2 root 2 equals to 3 root 2 y, and hence my equation of the tangent is 4x minus 3 root 2 y minus 2 root 2 equals to 0. So this is the required equation of the tangent. Similarly, let us write the equation of the normal. Then it will be, we know the equation of the normal is y minus y1 by x minus x1 equals to the slope of the normal. By looking at the slope of the tangent, that is 2 by root 3, we can write the slope of the normal to be inverse of this with opposite sign. Then it will be minus 3 by 2 root 2. So the point of contact is same, so it will be y minus 0 by x minus 1 by root 2 equals to minus 3 by 2 root 2. So let us simplify, then it will be root 2y by root 2x minus 1 equals to minus 3 by 2 root 2. On cross multiplying we will get 4y equals to minus 3 root 2x plus 3. Hence the equation of the normal will be 3 root 2x plus 4y minus 3 equals to 0. So this is the required equation of the normal. Question 7. Find the point on the curve y equals to x cube minus 3x plus 5 at which the equation of the tangent is y equals to x minus 11. See here, this question is different from the previous one because here we have to find the point of contact, and the given is the equation of the curve and the equation of the tangent is also already given. Now we have to say that this tangent of this curve is at which particular point. So for small visualization, let us make a curve and let us make a tangent at point P. Let the point of contact be x1 comma y1. So here this equation of the curve is given as y equals to x cube minus 11x plus 5, and the equation of the tangent is given as y equals to x minus 11. Now as I already said that this point of contact, that is x1 comma y1, which we have supposed, must satisfy the given equation of the curve, and this point also must satisfy the equation of the tangent. Given equation of curve, that is y equals to x cube minus 11x plus 5. So differentiating both sides with respect to x, we have 3x square minus 11. So the value of dy over dx at the point of contact, that is x1 comma y1, will be equal to 3 into x1 square minus 11, which is the slope of the given tangent. Now one concept from geometry, that if the equation of a straight line is given, then we can always find its slope by looking at the equation. So here the equation of the tangent, which is a straight line, is given as y equals to x minus 11. Now if I compare this equation with the standard slope intercept form equation, that is y equals to mx plus c, then if I compare this equation with this equation of tangent, then this y can be written as 1 into x plus minus of 11. So here my slope, that is m, is equal to 1. That means this slope of this tangent is 1. From here we got the slope of the tangent as 3x1 square minus 11. That means this 3x1 square minus 11 must be equal to this 1. So here, therefore, the slope of the tangent, that is 3x1 square minus 11, which we got from the derivatives, must be equal to the slope of the same tangent which we got from the concept of geometry, that is 1. So from here we got the value of 3x1 square equals to 11 plus 1 is 12, and hence the value of x1 square will be 4, and the value of x1 will be plus minus of 2. Now since we have got the two values of x1, and since this point of contact must satisfy the equation of the curve as well as tangent, so let us put the value of x1 in the equation of the tangent. So when x equals to plus 2, then if I put this value in the equation of the tangent, that is y equals to x minus 11, then it will be y equals to 2 minus 11, and I'll get y equals to minus 9. That means my point of contact could be 2 comma minus 9, or when x equals to minus 2, then y will be equal to minus 2 minus 11. So from here I got the value of y as minus 13. So my point of contact could be minus 2 comma minus 13. So since I have got 2 points here, but you know that point of contact is only 1. Now which point is the point of contact? To determine this, we should put this point on the equation of the curve and check, because if this point is a point of contact, then that point must satisfy the equation of the curve also. So let us put 2 comma minus 9 in the equation of the curve, and let's see whether it will satisfy the equation or not. So since my equation of the curve is y equals to x cube minus 11x plus 5. So let us check this point, that is 2 comma minus 9. Then here it will be minus 9 on the left hand side, and on the right hand side it will be 2 cube minus 11 into 2 plus 5, which is equal to 8 minus 22 plus 5. So this equals to 13 minus 22, and that equals to minus 9. That means this 2 comma minus 9 is satisfying the equation of the curve also. That means the point of contact is 2 comma minus 9 and not minus 2 comma minus 13. You can check this point also, it will definitely not satisfy the equation of the curve. So my answer is 2 comma minus 9. Show that the curves x equals to y square and xy equals to k cut at right angles if 8k square equals to 1. So there are two curves given, that is x equals to y square and xy equals to k. Let this be x equals to y square and let this be xy equals to k. It is clear from the picture that they are intersecting at this particular point, and let that point be p of x1 comma y1. Now the point is that if two curves are making right angles, that means if I make a tangent at this particular point p of both the curves, then those two tangents will make 90 degree with each other. So here I made a tangent to x equals to y square at point P, and this is the tangent to the curve xy equals to k at the same point P. So the concept is that these two tangents will also make 90 degree. So let us find the slope of these two tangents. So my first curve is x equals to y square. So if I differentiate both sides with respect to x, then I'll get 1 equals to 2y into dy over dx. So the value of dy over dx will be equal to 1 by 2y. At x1 comma y1 equals to 1 by 2 into y1. So let this be the slope of the first line and let us represent with m1. Similarly, the second curve is xy equals to k. So differentiating both sides with respect to x, here we will use the product rule. So it will be x into dy over dx plus y into 1 equals to k is constant, which will be equal to 0. So from here I got the value of dy over dx equals to minus y by x. At x1 comma y1 will be equal to minus y1 by x1, and let us call it as m2. Now since these two tangents are perpendicular to each other, the product of their slope will be minus 1. So this is the concept from geometry only. So the value of m1 is 1 by 2y1 into the value of m2 is minus y1 by x1, which will be equal to minus 1. So here y1 and y1 got cancelled, this minus and minus got cancelled. So here it will be 1 by 2x1 equals to 1, and hence the value of x1 equals to 1 by 2. Now in order to get the value of y1, let us put this value of x1 to any of the two curves, because the point of contact lies on these two curves and it must satisfy the equation. So the equation of the second curve is x into y equals to k. So the point of contact must satisfy this equation, that is x1 into y1 will also be equal to k, and since we know the value of x1, that is 1 by 2, then it will be equal to k. So the value of y1 equals to 2 times k. Therefore the point of contact is x1 comma y1, that is 1 by 2 comma 2k. And since this point of contact also lies on the first curve, so it must satisfy the equation of the first curve. So my equation of the first curve was x equals to y square. So let us put the value of x and y from the point of contact. So it will be 1 by 2 equals to 2k whole square. So this implies 1 by 2 equals to 4k square, and this implies 8k square equals to 1. Hence, we assumed that these two curves were at right angles, and on the basis of that, we proved that 8 times k square equals to 1. So that brings us to the end of tangents and normals. Thank you for learning with me. Keep practicing the problems, and I'll see you in the next chapter.